Okay, you're going to turn to your book on section 2.4 and you're just going to do problems 40 and 41. Okay, make sure these are in your notes, so if I do collect the notes, I can find them there. One of the questions we wanted to answer is there a way to narrow down all those choices? So we're going to talk about something called Descartes' rule of signs. Okay, I think the apostrophe is actually here and it's not there. All right, so if we were to go through the whole P over Q mess, okay, P would be plus or minus 1, 2, 4, 8, 16. That's going to be a lot. Q is going to be plus or minus 1 and 3. So you can already see that P over Q is going to generate quite a lot of choices. It's going to have 1, 2, 4, 8, 16. And then it's going to also have 1/3, 2/3, 4/3, 8/3, 16/3. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 choices because of the plus or minus. That's an awful lot to deal with. So Descartes actually came up with a way to narrow it down. What Descartes said is you can look at the sign changes in the original equation, and that will tell you how many positive roots you have. So for example, here we go from plus to minus. That's one sign change. And then we go from minus to plus. That's a second sign change. So what Descartes realized is, first of all, you have a possible 2 positive roots. So out of these, if you try the positive ones and you found 2 of them, you're already done and you don't need to go any further. However, there is a little bit of a detail. You always count down by 2 when you can. So 2 minus 2 or 0. Okay? So I just need to find 2 positive roots and then I'm done, or I might actually find no positive roots, which is a possibility. Okay, but how about negative roots? Well, what Descartes said is you can actually figure out how many negative roots there are by testing f of negative x. So if I plug in negative x, I'm going to get negative 3x cubed plus x squared plus 3x plus 16. And what Descartes said is, well, count the sign changes again from this one. So notice I go from negative to plus, and that's my only sign change. So there's only one negative 0. Okay? That means once you find one of these that work and it's negative, you don't have to test any other negatives. So Descartes' rule of signs, you count the sign changes for f of x, that's the number of positive roots. You count the sign changes for f of negative x, that's the number of negative roots. Okay, let's apply Descartes' rule of signs completely to this problem and work it out all the way through. So Descartes says count the sign changes. I see 1, and that's it. So Descartes makes life very easy here because I know there's only one positive root. Okay, so once I found that, I'm good. Again, Descartes says, though, we got to find the number of negative roots by plugging in negative x, so I get x to the 4th minus 4x cubed minus 13x squared plus 64x minus 48, okay? And we're going to count the number of sign changes from here, forgetting the original. The original has nothing to do with it. So I see one sign change from there to there, one sign change from there to there. So there are a possibility of 2, not positive, but 2 negative roots. Or remember, you can count down by 2, so 2 or 0. So again, we have to now look at the P over Q. The problem right here is P is going to be so much. Q doesn't really matter because it's just 1. So P over Q will be plus or minus all the factors of 48. 1, 2, 4, 6, 8, 12, 24, 48. Okay? There's quite a few of them, but look, there's only one positive one. So once we get the one positive one, we don't have to try any other positive ones.